Good morning, everyone. Uh, Today we'll start from Unit 3, where in Unit 3 we are going to discuss about heterogeneous catalysis. Mainly, we are going to discuss about what exactly catalyst is, its role in increasing the reaction rates, and the characteristics of the catalyst, and physical properties of the catalyst, mechanism of the catalyst, and action of the catalyst, and reaction rate mechanisms for various reaction resistances. And also at the end of this unit we are going to discuss about various catalyst preparation methods, catalyst poisoning and deactivation, and finally most important, the physical properties of the catalyst. Yes, our main objective is today's class, our main objective is to discuss about the following topics on the catalyst. One is characteristics of the catalyst, mechanism of the catalyst, and action of the catalyst. What exactly catalyst? A catalyst is a small substance used in the reactions in order to enhance the reaction rate by increasing the speed of the reaction without participating in the reaction. That means catalyst, let us try to take a Haber's process where ammonia is produced from the reactants nitrogen and hydrogen in the presence of the solid catalyst like iron. This catalyst, solid catalyst Fe, will not participating in the reaction, will not consume in the reaction, but it will increase the speed of the reaction by which the reaction rate will be enhanced. Another reaction is S plus of O2, oxidation of the sulfur in the presence of vanadium pentoxide as a catalyst will give rise to SO2. And 2 plus O2, again iron as a catalyst, 2NO3, CH3CH4, acetaldehyde, plus H2O2, hydrogen peroxide, manganese as a catalyst will provide acetic acid plus H2. CO hydrogenation reaction, CO when carbon monoxide is hydrogenated in the presence of copper produces carbohydrate HCHO, formaldehyde. HCHO is formaldehyde. Then now we are going to discuss about the characteristics of the catalyst. What exactly characteristics of the catalyst? First important characteristic is selectivity. Let us consider reaction A gives rise to D. A is my raw material called reactant, D is the product. But this raw material reactant will produce product, it will not produce product directly. It produces some intermediates like B star and C star. And these intermediates will consume in the reaction and produces finally the end product called D. Selectivity of a catalyst means it affects the reaction rates of selective reaction by leaving other reaction rates unaffected. That means catalyst only alters the main reaction. It will not alters the unwanted reactions. That means it will reduces the formation of intermediates. It will increases the formation of the end product. And another characteristic point is the requirement of catalyst for reaction is in very small quantities. And catalyst will not affect the equilibrium constant for a reversible reaction. Will never affect the equilibrium constant for a reversible reaction. And also with the presence of the catalyst, the activation energy for a reaction will decreases. That means catalyst provides an alternative path for the reactants to convert into products. This is what the alternative path. Without catalyst, this is the path. With catalyst, it provides an alternative path by which the reaction rates will be increases and the time of reaction will be decreased. Next topic is mechanism of the catalyst. What happens in a reaction? How a catalyst makes the reactants convert into products in a more efficient way. Let us consider reaction A plus B gives rise to R, where the reaction kinetics are altered by the presence of the catalyst by the following mechanism. In the step 1, what happens in step 1? Let us try to take a bulk phase of reaction where the reactants are at very far from the catalyst surface. This is our catalyst surface. This is your external surface of the catalyst. These are the pores of the catalyst. These triangular shapes are the active sites of the catalyst. If you observe here, my reactants are here, my catalyst is here. In the first step, the reactant particles are diffused. External diffusion of the reactant particles from the bulk phase to these particles has traveled from the bulk phase to external surface of the catalyst. At the end of the step 1, my reactants are on the catalyst surface. During the step 2, the reactants on the catalyst surface are internally diffused. This is our catalyst particles are internally diffused. There is a internally diffused. The second step is internal diffusion of the reactants from the external surface of the catalyst. This is the external surface of the catalyst to the internal pores of the catalyst. To the internal pores of the catalyst. That is our the third step. Reactants are right now we are at the inside. Step 3, adsorption of reactant particles on the active sites of the catalyst. In the third step, the particles are adsorbed. The particles are adsorbed on the active sites of the catalyst. Adsorption of the reactant particles on the active sites of the catalyst. This is what happens. In step 4, chemical reaction of the reactants into products on the active sites of the catalyst. During the step 4, the chemical reaction of the reactants, that means third step, adsorption of the reactants. Fourth step is chemical reaction of the reactants into products on the active sites of the catalyst. There is a reaction takes place. During the step 4, the reactants are converted into products. What happens in step 5? Desorption of the products. The products are formed. Again, the products are dissolved from the active sites of the catalyst. Step 6 is the internal diffusion of the products from the pores to the external surface of the catalyst. Internal diffusion of the products from the pores to the external surface. These are the products right now. Right now the products are on the active external surface of the catalyst. Now during the step 7, external diffusion of the products. The products are diffused from here to some bulk phase. That is called as the bulk phase. External diffusion of the products move from the external surface to the bulk phase. Now we are going to discuss about the action of the catalyst. Last topic for today's class is action of the catalyst. In general, the reactants initially produces intermediates. Later, these intermediates will convert into products. Converting intermediates into the products by the action of the catalyst, briefly discussed by the following theories. There are 3 different theories. The first theory tells about that. Theory 1 assumes intermediates are formed in the vicinity near to the catalyst surface. This is our catalyst surface. The intermediates are formed like this is a gas film. They formed near the vicinity of the catalyst surface. In the theory 2 assumes some forces will attract the intermediates. Here the intermediates are there. Some forces will attract intermediates towards the external surface of the catalyst. That is theory 2 tells about. Theory 3, it assumes intermediates are formed on the surface of the catalyst. Theory 3 assumes intermediates are formed on the surface of the catalyst. These are the three different theories which tells about the action of the catalyst. This is for today's